Welcome, everyone, and thank you for joining us for today's webinar. My name is Kevin Ho, and I'm a financial engineer here at Beacon Platform. Today, we are going to explore how Glint, Beacon's user interface development framework, can accelerate your application development and boost your bottom line. The presentation part of this webinar will be about 30 minutes, and we have allocated 15 minutes for questions at the end. If you have questions during the presentation, please type them into the chat box and we will bring them up as appropriate. Our presenters today are myself and Iris Cariotelli. Iris is a lead financial engineer here at Beacon. She leads user interface and UX development and also works with internal and external clients developing our front office applications. Again, my name is Kevin Ho, and I'm a software engineer and member of the client engineering team here at Beacon. I've been here for about 2.5 years with a background on the front end and UI UX development. And I'm really excited to be a part of today's webinar presentation. My personal focus is empowering both our application developers and our clients to go from idea to screen as quickly and as easily as possible. And now I will turn the controls over to Iris, who will kick us off with a high-level demonstration of Beacon's front office flagship applications to demonstrate the power of Glint. Thank you.
Thanks for the kind introduction, Kevin. I will kick off with a quick background about myself and what I do here in Beacon. I will then give us an overview of the Glint framework and then take us through a few applications that we have built internally within Glint, just to give an idea of the power of the framework itself. As Kevin said, here in Beacon, I look after our UI UX team. My background is in investment banking. So I have been working in front office engineering roles for about 10 years, and I've been in Beacon for about 3 years, and I look after our UI and UX team. We built Glint about 3 years ago, and we built it as a framework to enable developers to build functionality-rich, full-stack web applications entirely in Python. A key goal for us is to allow developers using the framework to build highly interactive applications without any required knowledge of the JavaScript ecosystem. As a fully integrated component of the Beacon platform, Glint applications allow for direct access to business and data analytics that have been developed within Beacon. As I said before, in the first part of this webinar, we will just take a quick look through a few of the applications developed using the Glint framework internally to demonstrate some of the capabilities. Just a point to note here is that the applications I will walk through have a financial focus. I won't be spending a lot of time in this webinar explaining the application functionality itself, and I won't be focusing on any other financial aspects, but I would like to just focus on the components and the user interface. So the first application I'll be showing is called Beacon Plot. Beacon Plot is an application we have developed that allows users to not only directly access and visualize data they have stored within the platform, but also manipulate it live and display the results. I'll take a quick walk through here. So the first point, just to look, is something that you will see across most of our applications. This is a common application header that we have developed and reuse across all the applications that we built for a common look and feel and common application-based functionality such as settings, help, error reporting, quitting, that type of stuff. So we don't rebuild it every time. And I just want to point it out as a principle of reuse. This is one component, but we build many components that are reused in that manner. It also is the home of the menu, and I'll walk through some of these functionalities later, which is obviously customizable by application. The headliner of Beacon Plot is obviously the charting component here. For this component, we use Plotly.js, which is an open source library. This is another common pattern for our components. We leverage extensively well-tested, well-built open source libraries within the framework. Plotly.js is a very powerful, highly customizable charting component with a wealth of support for things such as line charts, bar charts, area charts, 3D and 2D charts. It is very rich and can do actually a lot more than we just leverage it for in this particular application. On top of the open source component, we've added some of our own functionality, such as UI-based annotation and shape and access managers that the end users can leverage to change the plot without needing to edit any of its actual, in this case, JSON style inputs. So the next part of this is the second half of the screen. We obviously have some dates that allow us to control the x-axis, and we have the code editor. The code editor is really what allows you to do the second part of what I mentioned as the goal of this application, which is actually live manipulate and analyze and do analysis based on the data you have stored. So I'll walk through this example and explain a little bit what this language is. So these are effectively Python expressions, but there is some additional components to them, as you can see here with a hidden tag or here with a label tag, that control the charting behavior of each line. By default, the code editor will assume that each line you've written will be charted unless you've got the hidden tag on it. So the analyst user of this tool can define, say here, a currency pair, and using a common function that is exposed can load up the data, in this case the time series, for FX, Euro, USD. So historically, can take a look at the data available within Beacon for that time series for those dates and plot that. I will make an edit just to show you the change and also to show you that you can comment out any lines that you don't care about. So this is the pure time series as loaded out of Beacon. And then another function that's being exposed to the tool is rolling mean. So again, we can execute that and see a smoothed out curve calculated. And finally, we can do a vol calculation as well. These functions are functions that we've made available through Plot Tool. We can see a listing of them through here. This also shows us another layout component that's available to application builders. In this case, it is a model, as well as a virtualized autocomplete, which is a very efficient select style component for dealing with large amounts of data. These functions are all functions that are exposed into the expression parser of the code editor, and they can be customized by ourselves or our clients in their domains by adding their own custom functions. And we also expose all of Pandas' functions as well. So I could, for example, look up rolling mean here, get a little doc string, and insert it for use. Comes here. The final bit of functionality I'll touch on is loading and sharing. As these applications are directly integrated into Beacon, you can store data directly into the Beacon databases, and you can access plots that other people within the organization have shared. So for example, I can take a quick look at one of Anya's plots, and I can open it. I can also directly share a plot that I have been working on with another colleague in the same domain as myself. So by clicking share plot, I get a shareable URL, which will launch the application for them and open the same plot I've been editing. This concludes the walkthrough Beacon plot. The next application I will be looking at is even more financial in its focus. This is Market Stress Generator. Here, we start introducing the integration of Glint with Beacon and also with the Beacon financial representations and deal models. This application first has a set of selectors that select a given market environment, and subsequently the application itself analyzes this portfolio that I've picked. So I've picked this scenario and I know it has some commodity futures and options. And once the application knows it, it gives me a listing of the markets that these trades are exposed to. So in this case, we have some oil futures and some oil options. So we see crude oil here in its shorthand and nice print here. I will just select those two. I just want to point out how dynamically the screen updates. As soon as I've selected them, we get two new views injected in this collapsible panels. And they show us, starting from the selected date, the forward curve of those markets. Now, the aim of this application is to play around with possible shock scenarios, as in what could happen in the market and how would that affect the price of my book. So the application has also loaded the current value of this book and also has another field here called shocked value. We'll see in a second what this does. As I start to tweak scenario settings, I can, for example, pick one market, like crude oil, and do a 50% bump across the whole market. As I typed this, the graph updated. As the graph updated, it also updated the market data stored in Beacon and automatically recalculated the new shocked value of the book if the market really had behaved that way. And you also note that the original value remains here. We have the concept of keeping both states at the same time within the same application. I can reset that now and show a slightly more complex tweak where I've now run some mathematical analysis to identify patterns across those two markets. And so I can, in fact, select a different style of scenario. And I want to say, what if I bump these markets in a way that they would naturalistically move? These markets are highly associated. So usually if one goes up, the other one goes up. The analysis we did identifies that. And so by using this very first vector shock, it has shifted the markets in a more natural way to how they would normally behave. And again, the recalculation happens. I like showing this application because it gives us a nice idea of how powerful the interaction of Glint applications and the Grommet graph with all your analytics, your data, your market data, and your trades can be, and how quickly you can get an application that can leverage that efficiently. That concludes my part. I will pass the baton back to Kevin.
Thank you, Iris. Thank you for that rich, high-level walkthrough of some of our flagship applications created using Glint and its feature sets. Hey folks, thanks for the opportunity to show you a little bit about the Glint application framework today. And I would like to demonstrate for you how quick and easy we've made exposing your data in Glint and how much more interactive an application is when compared to something like a static report or spreadsheet. So jumping back a little bit more high level, what is Glint exactly? We saw this slide a little bit earlier. I want to just go over some of the information here. Oh, sorry. Glint is Beacon's UI framework in production usage since October 2017. For those of you familiar with React, the JavaScript library, Glint is a React Redux-based framework for bindings to Beacon's grommet namespace, something that Iris alluded to earlier, meaning it's how your server-side models can hydrate and sync data with the front end based on views you declare from the backend. We'll come back to this concept in a couple of different ways throughout my presentation, so please allow me to put a pin in that for now. Glint was designed to solve a very specific problem in its infancy. We wanted to abstract away the implementation details of web development on the front end and keep true to Beacon's promise of a single language-driven environment, Python. Unfortunately, as many of you may well know, the browser does not understand Python, right? Browsers like Chrome can only natively understand HTML, CSS, and JavaScript. And there's a lot of boilerplate, provisioning, and setup in creating a web application, deploying it, hosting it, etc. So Glint empowers you to create rich, full-stack web applications entirely from Python. This is extremely powerful, as we'll see later, in giving us access to data science libraries, ease of collaboration, proximity to your business logic models, and lowering the barrier to entry for web development in general. What this means is that your quants and analysts are now effectively application developers who can help R&D, prototype, and deploy end user-facing applications. A common pattern we see from clients is we've got all this stuff organized in Excel, but what we really care about is how end users can use all that data and calculations to drive revenue generating activities. And we think a dynamic application can be a lot more powerful and interesting than, say, reports or spreadsheets. So let's take a trivial example with a simple macros. Here I have a spreadsheet, actually a Google Sheet, a spreadsheet that has a cell B5 that represents the total price of something, say apples, so 20. And so B5 has a dependency on B1 and B3, B1 being the price per pounds of, say, apples, and B3 being the number of pounds that we own. And so 2 times 10 is obviously 20. And I use the word dependency here intentionally because, like some of you may already know, Excel, or in this case, Google Sheets, is already a common dependency graph implementation that many of us are already familiar with. Here at Beacon, we use Grommet. Grommet is the programmatic implementation of our dependency graph. So cell B5 here is a calculated node that has a dependency on cells B1 and B3. Just to start to use some of that language here. Again, cell B5 is a calculated node that has a dependency on cells B1 and B3. Let's see this exact same thing as an application. Here's a Glint application that does the exact same thing. We have two input numbers, this $2, this 10 pounds, so it's two input numbers, and a number label here that says $20 that represents the calculated output of 10 times 2. So naturally, if I update this to 20 times 2 is 40, and you see this automatically update to $40. No surprises there. So let's see how this looks like in code. Jumping back into the IDE, this is the Beacon IDE, which is our integrated development environment, both for clients and us working in Beacon. This may look familiar to many of you because the Beacon IDE is a customized version of Visual Studio Code, integrated and tuned to work seamlessly within the Beacon platform. As was previously alluded, our choice of common language here indeed is Python. So let's look at that code. Like I said, Grommet is our proprietary implementation of a dependency graph, and here I have a Python class, calling it model, inheriting from Grommet.object, which is a Grommet object. This is our graph right here, and we have three methods. These three methods represent three nodes. And taking out the UI layer bit, what we really care about is what is the price per pound of your apples? What is the number of pounds of apples you have? And therefore, how do we reflect that calculation to give you back the total? So the total price node here is the value of self.price per pounds and self.pounds. So price per pound here is returns 2 and 10 by default, and so total returns 20. If I change pounds to say 20 here, obviously total would become 40. And so reverting back to code for now. So taking this little script, there's some boilerplate here for creating a Glint application, and I can Control F9 to run the script. We'll dive deeper into what that is actually doing. But we can see that very quickly, our Glint application has launched a fresh new instance, and we can again change this to 55 and get $110, right? So we take these three Grommet nodes that we've already identified earlier, and we just map them into Glint components for the UI representation layer. So let's take a look at what happened when I ran the script. When I ran this script, Python boilerplate code runs. So line 58 gets run. The create app function is invoked. The create app function is invoked on line 32, which first we take on line 33, we take an instance of a Glint app in the constructor and we create an instance. We create an instance of that model on line 35 using the grommet.ns.new API, which is the same as calling model invoked. And so we have the instance of the app, we have an instance of the model. The model, remember, is a representation of our dependency graph. And now we create a variable called body content, which contains Glint components that we've assembled in a layout. So in this case, a container, and then the two input numbers as you saw, and the number label as you saw as well. Along the way, I've added helpful labels to see what those input numbers and number labels represent, and I've given it some formatting as an option. And notice that to map the Grommet nodes themselves, again, the nodes on the dependency graph itself, we simply have to just pass in the reference to, say in this case, model.price per pound to map to the first input number. That is this first input number right here. And we can map the second one, model.pounds, the second one, and then model.total is the number label at the end. Model.total represents what is used here, that number label at the end, and that model.total is mapped to the multiplication of the product of price per pound multiplied by self.pounds, just like that macros. We take that body content, we add it to the index view, something that Iris alluded earlier with the header that comes standard in Beacon applications, should you wish to use it. And that index view is then added to the application through the app.addView API. And then lastly, on line 52, we call app.run to launch the application. In this case, by launching the application in a new window, because we use index view, we get this meta component, this header view right here, that gives us some functionality such as the current database we're in, a drop-down menu of helpful things like an error reporter, dev tools, settings, etc. And so very quickly, as you can see, Not including the model, in less than 20 lines of code, we've created an application instance. We've set the layout and view. We've injected that view into the application with data bindings to the model. We've launched it with its contents being served from a Tornado-based Python web server, which in turn opens up a WebSocket. And because we've used the index view meta component, meaning a component that is composed of other smaller components, the application now comes complete with a prefabricated header bar with some functionality built in. There are many advantages to making this switch from spreadsheet to code, and I want to cover a few of them now. Since we're dealing in code and not spreadsheets, it's much easier and scalable to collaborate. We can decouple our logic and data away from an Excel implementation. And because it's Python, we have access to the world's collection of data science libraries and packages, what I call, quote, social coding, or to stand on the shoulders of giants, end quote. You can, of course, leverage libraries that you and your own organization have created. Your application sits on the back end alongside your model, which means you're right next to your data. You have version control with Git. You can inject dynamic views to control the UI, as we saw, and you can certainly customize how you want to visualize that data. And I know I've stressed this many times before, but because it's Python, the language of data science, your developers don't have to be web development experts in wrangling HTML for document layouts, CSS for styling, or JavaScript for interactivity. All of that has been done for you while also keeping you in full control in the driver's seat of how you want your applications to look and feel. And because it's code, it's debuggable, right? We can validate, traverse nodes, and we can write tests and control releases. Let me show you a quick test for that little pricing calculator we just saw. So here I have Glint grommet example test.py, and I can again run the script. It's a very short script, and you can see that 2 tests have passed. First test is we test a model instantiation. So we take that same model right here, just to refresh. We have the same grommet object model right here. We want to test first that it is an instance of a grommet object. Then we take that same model on line 25, we assert that its default total node calculate results to 20. And then if we do a set value to override the prices node to 50, we override the pounds node to 2, 2 times 50 becomes 100. So we assert that total. Now when I invoke model.total, we get 100, and this test passes. So you can see that as part of the beacon environment and the code control process, you can write tests to assert on your business logic for your Glint applications very easily. Going back to the slides, I want to talk about now about why we created Glint and where it really comes in handy. Often described as a video game-like programming experience, Glint was designed to make creating apps easy for Python developers. Glint exposes utilities such as common controls, layouts, and a built-in WebSocket layer to handle that connectivity to your data in the backend. There's therefore no need to be a UI expert to build and deploy full-stack web applications, thus amplifying the return on your R&D investments. A developer simply imports the components they need into their layout, configures the customizable attributes, such as the formatting you saw, or even passing in that data, and then by binding that component's value to the data, everything works as expected. And because Glint is a part of Beacon Core, its code is fully transparent, its features fully extensible. Glint takes full advantage of Beacon Core functionality. This includes features such as elastic compute and on-demand access to a distributed compute grid for large-scale models and datasets. Let's see that Python workflow in action now, shall we? So I'm going to open up, I'm going back to IDE, I'm going to open up something called appbasic.py, which is our Hello World application. This Hello World application is even simpler than the one you saw before. All we have is the basic create app boilerplate, where the body content now has a panel, some HTML just to show the functionality that you can, and a label. And the panel has a title, attribute quark passed in where it says this is a panel. So I'm going to run this application, Control F9 again, closing out the stale instance of my old one. And when a new application launches, you'll see, voila, we have the index view that we're familiar with, and we have the panel. There's some HTML, and this is a label. Notice that this is a panel right here, shows up as part of the title, and that's because we passed it in as title. And because we know that panel is a layout component that provides a section, we can give it a header in this case. So it's a very basic Hello World application. The rest is all the same. Let's make this a little more interesting. Let's add a button in. So I know that button comes from the controls library. So I can take that same button and just instantiate it directly into my layout. As expected, I'm going to make it say, click me. And because I know that buttons have to do something, they have to click. And on that click, execute a function, I can pass in a method or a callable. So under onClick, I'm going to give it a lambda. that just does print hello, just to stay within the theme. So if I did everything correctly, I'm going to launch this application now again, closing out the stale instance. And you'll see that we have a button now. When I click on the button, on the back end here, we have the word hello in the terminal. And notice here that the application itself represents your client side, but your back end, your server side, is in the IDE. So everything is server-side driven development. And we have a lot of advantages doing that, being that we're so close to our data and we can establish a source of truth. So along with that, let's take that button, which I know is a Glint block component, meaning it's a component that takes other components. I can put it inside of a label, meaning that I can take that same label and nest it inside a button. Nothing's really going to change here if I run this application again. Yep, just as expected. And we still see hello printed on the back end when I clicked on the button. Yep, so now let's add a little styling to this. So I want my button to be green. So I can type in background color and making that green. Again, running this application by passing in the styling object into the style. That is one of many ways to customize the look of your components and therefore the look of your application. It's a green button and functionality still stay the same. And then now, what if we were to take this button content, this click me right here, and make it more interesting? Let's set that value on graph, meaning that I'm going to create a grommet object and have label dynamically change at runtime. So first thing I need to do is I'm going to import grommet. Grommet. And I'm going to create a grommet object. So I'm going to have class, calling it model, just to be creative. Naming stuff is always a little tricky. At grommet.fn is our decorator for a grommet node. And we're going to call this button content, just to be self-documenting. And I'm going to return here, actually, the string, click me. And I'm going to use this button content as the value inside this label. First, I have to instantiate the model. So I can say model is equal to model invoked. Again, this is the same thing as doing grommet.ns.new. So this does the API for creating a new grommet object. And inside here, instead of where it says click me, I'm going to say model.button content. There we go. And if I did everything correctly, always a venture of live coding, nothing should have changed. Yep, there you go, nothing changed, click me, and still works just the same. But now let's make it a little more interesting. Let's add an input. So I know an input comes from the form library. Import an input. Just like an input number you saw earlier, an input number has been optimized for numerical displays and inputs. An input is for string-based displays and inputs. And so now I can take that input above the button and map it to the same node, the same model.button content using IntelliSense from the VS Code IDE. And what do you think will happen? For the developer audience among us, I have now tied this input to the exact same node as a button's label button content. What do you think will happen? Oh, I forgot one thing. I just realized I'm going to go back. I need to flag this with grommet.canset. The reason for that is because input is a form item component, and so it is actually doing a set value on the front end so that I'm able to override to edit. It makes the node editable, so that button content can actually change. So I can do grommet.canset. There we go. Now I'm going to rerun this application again and closing out stale instances. There we go. I have this input. Now, if I change this click me to say my name, Kevin, you'll see that Kevin is now the button content. I can change this Kevin to Iris. Same thing happens. If I click on the Iris button, The same on click still gets run, and I still get hello on the back end. And you'll see that as I changed each value, the button content got a few set value calls from the app server. This is logging that helps us as developers. So this hashed grommet binding ID for button content changed from click me to Kevin to Iris, but underneath the functionality did not change. And that's the data binding hydration that I was talking about earlier. When you pass in a reference to a model's grommet node, a binding is created for you under the hood. Bindings populate the data in Glint components, whether it is a text render for a label, the options for a dropdown, or the data in a grid or chart. Bindings enable client-side components to efficiently exchange data with the server-side code and update dynamically to reflect changes on the server-side model. Bindings can be callable or two-way. We saw that callable binding with the button earlier. Callable bindings are invoked in the client side based on a user or programmed action, such as clicking a button or meeting a condition. When invoked, these bindings execute a server-side function, for example, initiating a calculation, updating the model, or querying the database. Two-way bindings, something we saw with the button content, dynamically link the server-side data with the client-side component. As the underlying model calculates and updates, the UI stays in sync and repaints the bound component on the screen. Conversely, if a form item, for example, an input, were to receive new values by its user, the server-side grommet node that is referenced from the binding would also update its values to match, which is why we had to flag it with grommet.canset. By typing something into the input, this click me, the value for button content changed to Kevin or Iris. So let's make this a little more interesting. I know that I can, sorry, 1 second. I know that I can grab some dummy data from this import path right here. So if I show you what dummy data is, it is a giant Python object. And let me import pandas, the popular data science library, to give you a better representation of what that dummy data is. So if I do pd.dataframe with dummy data, there we go, we have a data frame. And you'll see that dummy data represents actually the date, open, high, low, close, and adjusted close and volume prices of the Tesla stock that I've downloaded from Yahoo Finance. So this is some stock prices, represents quite a large amount of data that we have pumped as from a Python object into pandas. So how are we going to let this pandas data frame be represented or exposed, and using our vernacular, expose in Glint in a quick, easy to do way? Let's show you how that works. So first, I'm going to import a component called virtualized table. And a virtualized table is a grid-like component or control that allows you to show data frames really nicely. So I know I'm going to do virtualized table invoked, and I know that it is the data parameter or the kwarg that I'm going to pass in pd.dataframe, just like you saw with dummy data. And of course, let's get those imports in. I'm going to do this import for dummy data, and I'm going to, excuse my OCD while I sort my imports, and I'm also going to import pandas as PD. If I did everything correctly, you'll see that the data frame has now been exposed in a virtualized table in an easy to read, clean way. Closing out the stale instance. There we go. We have a virtualized table that as I scroll, you can see we have the date, open, high, low, close, adjusted close, and volume of Tesla stock prices. This is, again, open source data from open data from Yahoo Finance. So I'm going to stop here because it's starting to look like a nonsensical application. I can do this all day, but hopefully that gives you a flavor for how quick and easy it is to iteratively develop an application, receive feedback, and make changes. So a common question we're going to have next is, what components are available to us using Glint? You can access the plethora of documentation resources available in many ways. First, let me show you how to run Glint docs. So if I run Glint docs, this is our documentation application, and let's just go to our old trusty friend button. Clicking on button under controls here. And it's important here and actually now to note that on the client side, the Python code written using Glint is transpiled into HTML, CSS, and JavaScript at runtime into a web application based on React and Redux. The React components are bound via the Redux store to the Python model and controller objects using WebSockets for data synchronization and remote function calls. So for button here, you can see, like some of our other React components, is actually a lightly wrapped version of an open source and design button, here with a link to the third-party documentation. It is, however, worth noting that our own JavaScript layer adds proper optimized grommet binding and function calling behavior. Many components are also made custom in-house, such as the virtualized table you saw. Some of Glint's open source pure dependencies include ant design, Plotly, as was alluded by Iris in her previous presentation, Moment, Numbro, BPMN, CodeMirror, Viz.js, and React Window. And above the links to the third-party documentation, we have also published an example app right here. And this example app can serve as boilerplate code to jumpstart your own usage of the component, as well as demonstrating its full feature set. It's a common recipe, basically. And we have over 150 to almost 200 example applications to serve as that boilerplate to demonstrate best practices and to serve as a canonical reference for all of our Glint components. Underneath that is our own FAQ page that you can link to. And in this FAQ page, it takes you to the documentation head of Glint as well. This repository of articles and documentation includes long-form reference articles, trainings, and tutorials, as well as any developer notes such as change logs. The documentation themselves include also a sandbox, actually, I forgot to show that right here, with a listing of available properties you can customize down here. So for example, earlier we used the onClick. All of our available props are listed here, as well as their typing and default values, if any exist. In conclusion, I would like to recap 5 ways that Glint helps developers reduce their time to market. 1. Full suite of UI components. Glint ships with a full suite of UI components and associated bindings to access and manipulate the state of the data on Graph, meaning Grommet, accelerating that full stack app development process. A dedicated team of engineers at Beacon supports, maintains, and releases new features daily. 2. Ease of provisioning and deployment of applications. The Glint runtime is packaged with the Beacon runtime. Developers do not need to worry about the logistics of hosting, servers, sockets, etc., eliminating infrastructure support needs and improving maintainability of the deployed applications. 3. Abstraction layer to the client-side ecosystem. Glint abstracts away the intricacies of HTML, CSS, JavaScript, and its cottage industry of client-side frameworks and libraries to a simple, easy-to-use Python-based library where the business logic lives, all accessible from a unified IDE experience. 4. Maintenance. The Glint team at Beacon assesses and curates the latest client-side frameworks and best practices, incorporating them into Glint. Developers building applications on top of Beacon automatically make use of the latest technologies and best practices available. 5. Model View Controller. Glint enables app developers to follow a well-established pattern of MVC architecture while promoting code reuse, delineation of concerns, and parallelization in the application development process. Let me now turn it back to Iris and allow you to ask us any questions or share any thoughts. And lastly, I invite you to download our Glint white paper if you'd like to learn more, and of course, stay in touch with us. Thank you.
Lovely. Thank you so much, Kevin, for that technical demonstration of Glint application development using Beacon. I'd like now to open the floor for questions from the audience. Please ping us your questions via the chat. And I would also want to give you a few ways you can stay in touch with us. Our email is info@beacon.io. You can find more information, of course, on our website, beacon.io. And you can also stay in touch with us via LinkedIn at Beacon Platform. As Kevin mentioned, we do have a Glint white paper available if you'd like to review today's presentation that also goes a bit deeper into topics such as customization and deployment, as well as the grommet binding and Glint relationship. Are there any questions? I see one question actually. It says, can I white label Glint applications to make them follow our corporate look and feel guidelines, or are they all Beacon branded? Kevin, would you like to take that?
Yeah, I can certainly. That's an excellent question. Yes, Glint has been designed to be highly customizable in many ways. Specifically, we foresaw an early need for applications to fit our client's own branding guidelines. So to that end, there are many ways to apply your own styling in a Glint application. Let me demo one more example application for you, which we call White Label app. So here, I'm going to open up White Label Pi, and I'm just going to run this application. Again, closing out stale instances. And so as you can see, this application looks quite different from the other applications you saw earlier. This app exemplifies a larger white label demo application with multiple views, routes, and models. So I can also switch my view like so and go to the plot playground view and load up a new plot from the database. If I go to load save plot, go to candlestick chart, and let me close this drawer. There we go. So again, this is using Plotly, a little bit of nonsensical data here, and switch the views again to equity app view. And here we have a table that has some pivoting. So I can go to operating margin and change that to an industry group. There you go. So as you can see, Glint comes ready out of the box and strives to be as user-friendly as possible, anticipating what we think are logical layouts and expected styles and colors. However, you can easily override them in a couple of ways. One, you saw earlier when I passed a background color as green to the style prop of button through simple parameter assignments. Two, at an application level, you can directly pass in a CSS style sheet header into the front end from the Python side using what we call a CSS render block. So here I have a CSS render block that is instantiated as part of the headers list. And we pass that list of headers to the Glint app constructor. And the CSS render block simply goes and points to an object path. The object path in this case is to this style sheet right here, which is just normal vanilla CSS. And three, because it's just Python code, you may extend our component classes entirely with preset attributes that fit your brand's needs when it comes to styling, layout, size, or even behavior. For example, you can create your own custom header bar, just like our index view right here that you saw. And here, this is a custom version of it that looks and behaves differently. And our intention is that you can reuse these across all of your domain's applications. Our intention is that developers using Glint would create specific prefab or purpose-built higher level components in Python, leveraging the ones that are already provided out of the box. Over time, a repository of pluggable components for particular use cases will naturally develop. As a transparent extendable UI framework, Glint fits nicely into the buy and build on top of philosophy of Beacon. Unlike other black box vendor solutions, developers have access to the full set of source code and are empowered to build their own components at any level in our stack. Hopefully that answers your question. Thank you so much. I see a second question here, actually. It says, what if I want to use my own components or libraries? Can I do that with Glint? Iris, would you like to take this one?
I'm back. Sorry.
Oh, hi. Hi. We had a little
I
lapse in
lost.
technical difficulty there.
Yeah,
I
I don't
said,
know. It has
the
indeed.
question from the audience was, what if I want to use my own components or libraries? Can I do that with Glint? Iris, would you like to take this one?
Yeah, definitely. That's a lovely question. Yeah, we recognize that many of our clients have JavaScript teams that build their own components, have components that they have licensed and they would like to use within the context of their Beacon applications. To that end, we expose Glint as both a runtime but also as a library that you can import in your own JavaScript project. So we expose all the Glint core components that we build and also the mechanism for coupling those components with your server communication and grommet graph. That way our clients can maintain actually their own projects, fully using our entire infrastructure and adding the components that they would like to use. That also gives them extra control in deployment and full control on when they want to update their JavaScript builds. Great, I hope that covers it. I see one more question here. It says, what's the difference between the charts in Beacon Plot and Market Stress Generator? So those are the two different applications I showed. I can also take that one. We have, as you obviously noticed, the chart components in the two different applications actually have a different look and feel. As I mentioned and Kevin repeated, the Beacon Plot uses Plotly.js. Market Stress Generator actually leverages a different open source library called Recharts. It is a less powerful charting library, but has a very simple API. And for simple use cases, it comes out of the box with a nice looking theme and pretty transitions. So if your application doesn't require a lot of richness and interactivity with the graph, it's a nice quick fit. We occasionally include libraries that address the same space because often, especially in the most complex use cases like charting and grids, one library has strengths where the other has weaknesses and vice versa. Um, I I think that's it. If there are any other questions, you please feel free to reach out to us and we'll make sure we answer them. Thank you all for joining us today. Please reach out to us. If we did not get the opportunity to answer your question, we will follow up afterwards by email. You can use info@beacon.io and you'll be also sent a recording of the webinar shortly. Thank you all very much for joining.
Thank you so much.